All right, I don't think I can do anything in mathematics if I didn't know about these certain properties. So today we're going to talk about important properties, or I guess today, in this video, it could be, maybe not today, I don't know, we could theorize about that a bit, but all the same, mathematics would just not work if we didn't follow certain rules. So these are less like rules as to just truths that will always hold, okay? So for example, let's pretend that you are out in the middle of this boat and somehow it's during a flooded season, you've parked this boat and you didn't realize you parked it on top of a big rock or some sort of cliff. Flood season goes away, you come back into the boat, and I suppose you wouldn't actually be in the boat if this were the situation, but let's pretend you have this person in this boat and you have this, the motor of the boat, okay? And let's pretend they weigh exactly the same amount. It's going to be precariously balanced on this cliff. Both of the sides of the boat are absolutely equal, okay? Both halves of this boat are equal. They look different, but they have the same weight. Well, an addition property tells me, and this applies to math, however, just think about it in the kind of a context of some sort of truth. It says that I can add anything to one side of this well-balanced boat, okay? This would tip over. But if I add the same thing to the other side, okay? If I add the same amount of weight on both sides, then I'm good, okay? This will remain equal, it will remain balanced, okay? I can do that, that's the addition property. It also works with subtractions. I can take away the same amount from both sides and the boat would remain precisely equal, okay? Multiplication means I can double it. I can double the amount that is on the side. So let's say we had two people over here, okay? We had two people over here, we had one person over here, but the weight is distributed exactly the same. I could double it. I could add two more people. So into this boat. Why would we add more people into this boat? Maybe it's not people, maybe it's coolers. We would add coolers into the boat, and the coolers weigh the same amount as a person. Or maybe the cooler has 3 fish in it. You'd have to add a cooler with 3 fish of equal weight onto each side. It doesn't matter. The fact is that as long as we are adding or multiplying or subtracting, and as long as we're dealing with the same increments of weight on both sides of this well-balanced boat, it will stay balanced, okay? What I cannot do is I cannot take something away from one side or just say, you know what, we're going to cut this part of the boat in half or cut the weight in half and expect it to stay balanced. That's what we cannot do. So these properties of equality describe this truth, and we use that to be able to build and manipulate numbers, okay? And we manipulate these numbers so we don't actually have to go and build a boat and be placing weights to figure out, hey, is this gonna work or not work? And this is kind of broken down in a very simple fashion. This is something that you learn way early on in grade school and then in middle school. And in high school, we apply it even further as we get into multi-step equations. And the multi-step equations become bigger context, more than just a boat. It's like if I'm going to send a launch shuttle into space, okay, and I want the weight to orbit, but I have to balance, okay, how much gas was burned or how much fuel was burned when it got into space, because the weight from Earth is going to be different when it actually reaches the outer part of the atmosphere, and I need that weight to continue in orbit. So that's where your balancing equations comes into play. I need to have all this figured out before I actually launch the rocket into space. Okay, so let's try this. So I'm going to erase this picture, and we're going to try this with some random numbers. Okay, so let's do, I like that color. Let's do this one. So let's say we have 1 and 1. Okay, I can add whatever I want as long as I do it to both of these expressions. All right, so this is an equation because it has an equal sign. I have two expressions here, so let's add 2. As long as I'm adding 2 to both of these expressions, it will stay balanced, it will stay equal, okay? Let's say I want to subtract something. Let's say I want to subtract, 2 from this side, but I want to subtract 1 and 1 on this side. Why would I do that? Because I'm subtracting 1 twice. It's the same thing as minus 2. It looks different, but it is the same. It'd be like in my boat, I added 1 person on one side, but I added 6 fish on the other side, but they're equal weight, so it's okay. All right, so here I got 3 minus 2 is the same thing as 3 minus 1 minus 1, okay? 2 expressions, they're still equivalent. I can simplify them, all right? So let's look at an algebraic expression, okay? Because this is where it kind of meets the road a little bit more. Let's try, I'd really go to 1 step. Let's try 2 steps, okay? We're gonna try a 2-step equation. So I got 2x plus 3 equals 12, and I sure hope this works. I hope the numbers work out nice. All right, so I have 2 expressions. This looks different from 12, but we're saying it's the same as 12. This could be a really heavy motor on this side of the boat, and this could be 2 people and 3 fish in a cooler, all right? So there's my expression. It doesn't matter right now what it represents. It's the fact that we're gonna apply these properties, all right? So what can we do to this? Let's use the addition property. I have the students in my class who say, hey, add 3. I'm saying, all right, I'm gonna add 3. I'm gonna do just that. I'm gonna add 3 to both of these expressions. Some people put a line down the middle saying, okay, there's my little rock, it's teetering. Whatever works for you is fine, okay? Well, what now happens is I have 3 and I have to add 3 to this 3. Those are like terms. I can't add it to this 2x because that has a variable in it, and you can't combine constants with variables. You just can't do that, all right? So that's another video for another time. So here we go. We got 2x plus 6 now, right here, and I got 12 plus 3, that is 15, okay? And it's fine, you can do that. Did it get us any closer to figuring out what that missing variable is? It didn't. So what we do is we look at these properties and say, strategically, what can we do to simplify this? And what I would do is, well, if I had subtracted 6, positive 6 minus 6 gives me 0. So that eliminates, that's like taking those 6 fish in that cooler out of the boat, which means I now have to take the same weight from this other side of the boat, or have, like, just to keep that analogy going. So this becomes 0, which is why I can just go ahead and write 2x there, because positive 6 minus 6 is 0. 15 minus 6 is 9, okay? And I would have got the same thing if I subtracted 3. 12 minus 3 is 9. 3 minus 3 would have been 0. But instead I added 3 and we got here. So again, the addition property of equality, it keeps it equal. You can do it, but is it going to help you simplify it? No. So you want to choose which property is going to help you actually simplify this problem. Now I could add or subtract again, but that's not going to help me. That's just going to add more to this expression. So what I'm going to do is I'm going to look here. This means multiplication. In order to undo this, or in order to simplify this, I'm going to divide by 2, because 2 divided by 2 is 1. So it's like I'm taking 1 person out of the boat, now I only got 1. I could have done this with a different one. Divide by 3, and then I'd take 2 out of the boat, and I'd have 1 left. But all the same, if I divide this in half, I got to divide this in half. And what that leaves me is, ooh, that didn't work. Okay? What that leaves me with is x, or 1x. That's just 1x, that's fine. I'm not going to put the 1 in front of there because that's just convention. That's what us normal mathematicians will do. 9 divided by 2, that is 4.5, or 4.5. Okay? So using these properties, that is how you're going to be able to simplify these expressions. Okay, and we'll have more on different properties and how to solve, but it is so important to note these properties. And I'm going to do another video to cover these purple properties.